Hello there. This is a question on stress. So the diagram shows a simplified model of a building with four identical heavy floors, which is horizontal. The spacing of the bottom floor from the ground is twice that of the spacing between the floors. So if we can just label this, for example, if the spacing between each floor is just h, and this is h, and this is h, therefore the spacing at the bottom rods will be 2h, which is double the height. Okay, between each floor are equal numbers is not mentioned, let's just assume it to be 2 of vertical steel supporting rods of negligible mass compared with the floors. Now the rods are of different diameters so that the stress in each rod is the same. So what we can know here, where is the point of stress between the floors as well as the vertical steel? Basically, it's where the point of contact is located at. So let's say, for example, this one is stress 1, which is floor number, the top floor. Let's just label the top floor as 1. And here will be stress 2, here will be stress 3, here will be stress 4. Okay, so it says here that the rods are of different diameters in order to ensure that the stress in each rod is the same. So that means here you have the diameter. Okay, just erase this. That means the diameter of rod number 1 is, let's just assume it to be, so when the diameter, that means the diameter of the rod, you can just label it as A equals to pi d over 2 squared. Okay, so you can just use instead of the diameter, because we want to omit the effect of the square, so just assume it to be an area A1. Here is A2, A3, and eventually the diameter for the fourth one, which is A4. Now, in order to ensure that the stress, stress 1 is equivalent to stress 2, is equivalent to stress 3, is equivalent to stress 4, the areas or the diameter is different from each other. Okay, so this is intuitively consistent. Why? Because we know that the formula for stress is equivalent to the force divided by the area. So if the areas are not the same, that means the force is also not the same. So because we know that this is basically a model of the building with one floor on top of each other, so that means you will have, let's say for example, the most bottom rod will have an accumulated amount of forces that is piled up on top of the most bottom one. Okay, so let's say for example here, for each floor, we assume it to be uniform. That means there will be one weight acting downwards. So here will be another weight, W and W and W. So the force that is acting on the first vertical rod would be just, let's say for example, we divide it with two rods, which is on the left and right. Although we don't really know what is actually the total number, we can use it as a generic n, but just to make it simple, we just assume that the force is basically W over 2. So this will be the first force at the top rod. So that means for F2, it will be accumulated of not only the weight due to the second rod, the second floor, and this is the first floor. Okay, but it is also because the first floor is on top of the vertical rod and the vertical rod is on top of the middle rod. So given that it says here negligible mass, the vertical steel supporting rods has negligible mass, so we assume it to be 0, which is actually not really that realistic. But here you have W over 2 as well. So W over 2 plus F1. So you have F2 will be equivalent to W over 2 plus F1, where F1 is equal to W over 2. And as you go downwards to the bottom floors, So you will have the same scenario. So here, eventually F4 will be equals to W over 2 plus F3, when in fact, if you go through substituting everything, so you'll get the fourth floor, the total force will be equivalent to 4 times W over 2. Okay. So the question is asking, what is the ratio of the diameter of bottom rods against to the diameter of the top rods? So here we know that stress 1 is equivalent to stress 4. So now we can use this formula where stress 1 is equivalent to F1 over A1. So what is F1? F1 is basically just a single weight distributed by the number of vertical rods divided by area 1. Okay. Then stress 2, or let's say for example you just take stress 4. Stress 4 will be equivalent to F4 over A4. In this case it will be 4 times W over 2 divided by A4. Now what we want is basically the ratio between the diameters of the bottom rod, which is D4, against the diameter of the top rod, which is D1. So since stress 1 is equivalent to stress 4, therefore W over 2 divided by A1 is equivalent to 4 times W over 2 divided by A4. So A4 divided by A1 is equivalent to just 4, because the W over 2 cancel out between each other. Now, so area is given as pi d squared over 2, where we know that area is going to be equals to pi over 4 d squared, where this pi over 4, when you have A4 over A1, they will cancel out the pi over 4 term, so you will left with d squared. So therefore, this one would eventually give you d4 squared over d1 squared is equivalent to 4. Therefore, the ratio of the bottom rods, which is D4, against the diameter of the top rod, which is D1, will be equal to the square root of 4. Here you get is equivalent to just 2, whereas the answer is A. So it's a bit gaslighting lah, if you want to consider the height basically does not play a role in determining the amount of stress that is placed onto the vertical rods.